experiment that you guys see all over the place where you take milk, and in my experience, whole milk works the best. And we're going to talk about why that is. You're just going to pour it in a plate. Try not to make a mess. Or make a mess, go ahead. Because science is, messy. All right, there, word it in there. Why this works is in milk, there's a lot of protein fats, right? So it's a lot of protein and fat and water, right? And soap is bipolar. So it's hydrophilic and it's also hydrophobic. So it really, really loves water, which is hydrophilic, and it goes after it, and it's going to break up the surface tension, right? So all of that is super cool and super neat. But it's also hydrophobic, which means it's scared of water. All right. So the part that's scared of water goes after those fats, those proteins, right? And it breaks them down. It goes after them and the proteins, and they love each other. So, right? Okay, so now you're going to take the soap and you're going to put your Q-tips in it. You guys see that? I usually take like 3 or 4 Q-tips, and this is just soap. And we're going to put it in the middle. Can you guys see this? You see the plate? All right, cool. All right, let's put this in there and see what happens. All right, ready? Go. Whoa, you guys see that? So it's really, really attracted to the soap. 3, the water and the dye need to get out of the way. Move, get out the way, get out the way, get out the way. So that the fat in the milk and the soap can be like, just the 2 of us, we can make it. And they get together.
Just the 2 of us, we can make it if we try. Just the 2 of us. Just the 2 of us. Just the 2 of us. Floating castles in the sky. Just the 2 of us. You and I.
And so this thing continues to dance and move around, and the color and the water just woo, trying to get out of the way so they can have their little bonding moment, right? And so that's what happens. So this will dance and move around until all of the fat protein molecules have found a partner in the bipolar soap. It literally sounds like a soap opera. Wait, soap opera. Oh, I literally just made that connection. Soap opera, get it? This is a soap opera, right? So the bipolar soap that is hydrophilic, which loves water, but also hydrophobic, is scared of water. If that's not a soap opera, I literally don't know what is. Goes in to where the water is, but in the water it finds these protein molecules and be like, no, I'm totally scared of the water, who I totally also love, but I'm gonna be with you. And then they like get together. And then that's what's happening. It's an entire soap opera up in here. And the water and the dye is just like, let me just get out of the way. Because it's way too much drama for me. I just cannot, right? So it breaks up the surface tension. But you know, the drama of soap. I literally just made that connection. My own mind is blown about soap operas. Now somebody needs to tell me the history of soap operas. Is that where it comes from? Because like soap is bipolar and hydrophilic and hydrophobic, where it loves water, but it's also feared by it. All right, so you guys just grab some milk, grab some soap, grab some food dye, some Q-tips, and check it out. Make the water and the dye move. Get out the way! Get out the way! Get out the way! So that the milk, fat proteins, and the soap, bipolar, hydrophilic, and hydrophobic molecules can get together. Get together. All right, guys, that's it. I gotta get. All right, stay curious and keep on sciencing.